Okay, great. All right, thank you for coming out. We're going to talk about some new Pinecone AI tools. And I apologize in advance. These things are so new that I've not had time creating demos for them yet. We literally announced these over the last week. A little bit about me. I've been at Pinecone now for 2.5 years, but I've been working with distributed data systems for over 20 years. If you want to connect on LinkedIn, that's my QR code right there. If not, then that's fine. Okay, so jumping right in. When you work with RAG, a typical RAG pipeline is going to have multiple components to it. Obviously, you have your corpus of vectors. Beyond that, the initial retrieval, whatever that number is, typically small. You're going to run that through a re-ranker to get more specific context, and then that's all going to come out to generate a single response from the LLM. So you might start with 10 million vectors, get an initial 50, winnow that down to 5, all to get one response. So there's a lot of hoops jumping through there. The architecture will typically look something like this, where you have the user inputting their text, you have the hosted models and the index all separate. Again, a lot of hoops to jump through just to get an answer to your end user. So what we're doing is we're simplifying all this. We're putting embedding and re-ranking models right into the vector index itself. The reason why we're doing this is because powering high-quality retrieval is really hard. Like I've said a couple times, there's a lot of moving parts. And any one of these things could go wrong. So we want to simplify it as much as possible. We want to make it as simple as possible for you to get into production quickly. So there's lots of vendors that you can use. We're going to blow past this one real quick. Actually, this one too. Okay, this is the important part. We're creating a composable platform for knowledgeable AI. And what that means is the embedding model, the retrieving model, and the re-rank is all in the same place as your storage. You have a single API that does everything for you. You don't have to worry about connecting multiple systems together. It's just a single API key and a single API call. Again, making it as simple as we possibly can. Embed, retrieve, re-rank, single API. Okay, so how does this work? So we have standalone endpoints for models hosted on our architecture. This is all running on a serverless platform, so it scales as you do. There's nothing for you to configure, nothing for you to install. You just take your API key and run. We're going to blow past that one as well. Okay, re-rankers are the unsung heroes of RAG. The reason I say that is that when you do an initial query against a vector store, whether it's Pinecone or one of our fine competitors, and you get that initial context back, those are similar results, but they're not necessarily pertinent. The re-ranker is used to find just the pertinent results in that body of similar answers. So as an example, you have a chatbot. Let's say you have let's say it's a help desk chatbot, right? Support ticketing system. Your customers go to your website, they're asking for help. How do I create a widget? Well, the initial responses are going to come back from the vector store is going to be anything related to creation, anything related to widgets, not necessarily creating widgets specifically, right? It's going to be similar to the semantic intent of the sentence, which may not be completely pertinent. When taking those results and running them through the re-ranker, that's when it can winnow down to just the most pertinent results. All right, we're going to take a step back and talk a little bit about LLMs and how they work. So some of the LLMs that are out there now have massive context windows, hundreds of thousands of tokens. But just because they have a large context window doesn't mean they actually understand what's in the middle. Statistically, they're really only going to look at the first section and the last section. This is why re-ranking is so important. It makes sure that the information that gets sent to the very top of the context window is the most pertinent, most relevant. It increases the accuracy of the LLMs significantly, as you can see on our chart here. And providing a single endpoint to do all of this, well, I'm repeating myself. It's a simplified integration to do all of it in one go. Pinecone is completely serverless. I mentioned that before. Everything you do with Pinecone just scales natively. Excuse me. It'll scale automatically, handling the inference as well as the embedding and the vector results. And all of this is accessible within Pinecone's integrated knowledge platform. All right, who knew that we host models? I see like no hands. That's actually kind of cool. This is really new. We just started hosting models very recently, and we came out with some additional ones, including Pinecone Sparse English v0. As its name suggests, this is the very first version of it. But it scores significantly better on NDCG than BM25. This allows you to again, leverage a single service to run your sparse embeddings as well as your dense embeddings, which we'll get to in a minute. We also have our own re-ranker. Again, V0, this is the first version of it. It's built to meet the demands of modern, large-scale applications. And again, this runs all in Pinecone's serverless infrastructure, so it will scale as you do. All right, that's a wall of text. The important part is that in addition to our own models, we are also hosting Microsoft's multilingual E5 Large. We also have BG re-ranker V2M3 as an additional re-rank model. And these are available to any Pinecone user. And again, single API key, you can run your inference and your re-rank all in the same service. We also have a close partnership with Cohere, and we host their re-rank model as well. Excuse me. Okay, this is an interesting one. Cascading search. This is a brand new service. It literally came out last week. The way this works is it's a form of hybrid search. The reason I say it's a form of hybrid search is because it actually takes dense vectors and sparse vectors from separate indexes, re-ranks them for you into a single result. Rather than trying to store dense vectors and sparse vectors in the same index, which is difficult and prone to error, we decided to split them into their own indexes, but run them through a unified re-ranker to get the most relevant results back. This allows us to have 24% better performance than dense and sparse retrieval alone. It's a much more effective way, a much more efficient way of hosting dense and sparse vectors together, rather than trying to treat them as two versions of the same thing, which they very much are not. Does everybody know what a sparse vector is? I see a few hands. Okay. Does everybody know what a dense vector is? A few more hands. Okay. So just to kind of lay the scene here, a dense vector is a collection of floating point numbers. It's a numeric representation of data. The reason it's dense is that every single dimension of that vector has a number. Anywhere from, typically it's from -1 to +1, and everything in between. Sparse vectors only have values for very specific tokens in the context. So you might have 4 billion dimensions on a sparse vector, but have 3 or 5 or 100 actual entries. And those entries will correspond to specific words or tokens that are part of the sparse model's training. Is that clear? Cool. So yeah, so this is a purpose-built platform specifically for AI retrieval. We do the embedding, the retrieving, the re-ranking of the sparse and dense vectors, a single service. All right, this is the last thing we're gonna be talking about tonight. And this is, again, this is brand new, it just came out last week. It's something people have been asking for a long time, and it's Pinecone Local. So production-grade AI apps in general need a lot of thorough testing, right? You have to set it up in your CI/CD pipeline, and you have to integrate all of your services in one place. Scaling up and down those resources can be computationally expensive and time-consuming. Even if you're using a serverless service like Pinecone, it still takes time for an index to be populated and come online and then to be taken offline. We want to simplify that as much as we can. It also, the Pinecone Local also allows you to have more control over your infrastructure. You no longer have to connect to Pinecone to do your initial testing. You can just run it locally in a Docker image and be off and running. So our initial milestones are to have control for the data plane as well as the control plane. Those are available now. In the future, we'll support more complex database features. For example, right now, it doesn't support Pinecone Assistant. It doesn't support sparse vectors. Those will come later. For now, it does support dense vectors up to 100,000 vectors in a single instance. Important caveat, it is not persistent. It's not designed for production. It's designed for development. So once you take the Docker image down, those vectors are gone. So make sure you have a copy of them somewhere. This is the Docker pool. If you want to take a picture of that and save it for later, this is how you get started with Pinecone Local tonight. I see cameras out, so I'll wait a second, let people take shots. All right, cool. All right, that is all I have for you guys tonight. Do you have any questions at all?
Testing. All right.
Sorry, I can't hear you.
I'll try to be louder.
That's okay. He's bringing the microphone.
Oh, thank you. Thank you so much, Cory. Yeah, so currently
Currently we're using Milvest, right? It's open source, and we have hosted on GCP, and we have been looking at other tools, right, like Pinecone, and basically scale our pipeline. And we saw that there are some. Basically, you have to hire an engineer who has to constantly debug new things that Milvest keeps coming out with, right? So I want to understand, like, what is, like, I know Milvest was the first one to came out with hybrid search, or at least we could kind of implement it there easily. So the newer things that are coming out down the lane, I want some light on that. Like, I know you mentioned a few things are coming out, but what are the further things that you're planning to bring in into Pinecone?
Okay, so for those who didn't hear the question, it's a roadmap question, right? You want to know what else we have coming?
Yeah.
I wish I could tell you. And it's not because it's a big secret. It's just because I spent a week on my feet in Vegas for reInvent last week. My mind is still a little soft, so I honestly couldn't answer you. I'm sorry.
No problem. Thank you so much.
You're welcome. Anybody else? Got one down here? Oh, back there? Okay.
Sort of a broad question. What are some
Sure.
open problems in this space that aren't getting solved right now? Have you passed by anything you would work on if you had unlimited time?
What are some problems in the space that aren't being worked on? LLM reasoning. Everybody's focused on using LLMs to essentially serve as an NLP gateway for customers, for end users, which is great, and that's a great use for them. But they could do so much more than just search and retrieval. Having a way for an LLM to actually reason through a problem and to share insights within itself before giving an answer, I think would be a huge step forward. As one example, if you're talking with ChatGPT and you ask it, give me 8 bullet points for a presentation, it doesn't know what the 8th bullet point is until it prints it out, right? So, because it's purely just a probabilistic machine. But if it could have a way to think before answering, I think that would be awesome.
I'd like to talk to you more about that later. That's interesting.
Yeah.
All right, more questions?
This guy down here?
I have a question about long context windows. So,
Sure.
So we use it, and it gives us very good results. And we heard this logic that in the middle it loses context, but in the attention mechanism there doesn't seem to be anything that gives more weight to any position than the other. But how is this like? I'm not. Are there any theoretical, any underpinnings as to why the middle context is lost?
So it kind of depends on the model and how the model is trained. But as a general rule, it's going to process the part of the context that came first. By the time it gets to the middle of it, it's already started giving its answer. Does that make sense? It doesn't necessarily read through the entire context before outputting an answer. It'll start reading it and then start giving an answer. So it's related to the problem that we were just talking about with reasoning. It doesn't think before it talks. It gets an answer and starts spitting it out.
But if from what I understand, the context window does is like it's basically a matrix multiplication, and positional embeddings are added post to it. So it does not know, like there is no special weight to any particular position. So it like long context windows, unless like after attention the other layers have any other things going on.
Yeah, so statistically, you get more accurate results with smaller context windows rather than larger, even on models that can handle large ones. Because again, just because it can store 100,000 tokens doesn't mean it's going to process all 100,000 before it starts giving an answer. And one last one back there.
Thank you. I have a question about your solution. So that the API, the serverless thing that you're serving, does it include the accelerating in terms of the software side too? Or is it about the model that you serve is accelerated?
I'm sorry, I missed the middle part of that myself.
So does it include serverless accelerating infrastructures also, such as like batching or kind of technology things? Or I was just interested in like your Pinecone model is like maybe LoRa or in somehow that kind of accelerations.
Right, we do support bulk upsert directly to the vector index, but we don't support batching to the models themselves yet. That is a future feature.
Okay, thank you.
All right. Thank you, everybody, so much for your attention. I'll be around if you have any questions later.